Higher Maths 2019 Paper 2 Question 1. We had this picture and A was minus 5 minus 12, B is 11 minus 8, and C is minus 3 minus 3 6. And fairly standard, find the equation of median, then the altitude, then the point of intersection. So the median of BD, so just working out exactly what it's asking me. This is the median they're asking us, so we're cutting this one in half. So I need the midpoint of A to C. So part A, I'll call D as the midpoint of A to C. So we've got minus 5 minus 3 divided by 2. And we've got minus 12 plus 6 divided by 2. That's minus 8 over 2 is minus 4. And that's 6 over 2, which is 3. So we get our midpoint of minus 4, 3. So that is minus 8 over 2, which is minus 4, and minus 6 over 2, which is minus 3. So now we can do our gradient between D and B because we don't know anything about it. It's not perpendicular. So the gradient of B to D, y2 minus y1 over x2 minus x1. So I'll just use minus 8 minus minus 3 on the top, and 11 minus minus 4 on the bottom. So you've got minus 8 plus 3 is minus 5, over 11 plus 4 is 15. That equals minus a third. So y minus b equals mx minus a. You can use either the midpoint or point B. I'm just going to use the one that's sitting right here. So I've got y plus 3 is minus a third, x plus 4. So I can do 3 times y plus 3 is minus 1 times x plus 4. Taking the denominator away, 3y plus 9 is minus x minus 4. Or 3y plus x equals minus 13. And we're done there, and that's fine. So for the altitude, we are going to need to find the gradient between C and B. So just a reminder, C equals minus 3, 6. And B was equal to 11 minus 8. So our gradient is equal to minus 8 minus 6 over 11 minus minus 3. That's minus 8 minus 14 over 14, which is minus 1. So the gradient of our perpendicular is equal to 1 because m1 times m2 equals minus 1. And then we need a point. So for altitude A to E, we can use point A, minus 5, 12, minus 5, minus 12. So our point A, minus 5, minus 12. So y plus 12 equals 1, x plus 5, or y equals x. 5 take away 12 is minus 7. And we get our second equation. C, find the coordinates of intersection. So we've got two equations, solve them simultaneously. So our first equation was 3y plus x is equal to minus 13, and our second equation was y equals x minus 7. So making them both look the same, I'll have 3y plus x equals minus 13, and I'll have y minus x equals minus 7. We can add them together to get 4y minus 13 plus 7. Minus 13 minus 7, minus 20. So y is equal to minus 5. And now to get our x, y equals x minus 7, remember. So minus 5 equals x minus 7. So x equals minus 5 plus 7, 2. So our point of intersection is 2 minus 5. And we're done there. Integrating a polynomial. SQA Higher Maths 2019, Paper 2, Question 2. Integrate this polynomial. So we need to get it ready to integrate, just like with differentiation. So I'm going to change that to the integral of 6x to the half minus 4x to the minus 3 plus 5. And then we can integrate because we add 1 to the power and divide by the new power. So that gives me x to the 3 halves. Still times 6, but that's divided by 3 halves. We'll deal with that later. And then minus 4x to the minus 2. Minus 3 add 1 is minus 2. So divide by minus 2. Then plus 5x. And then remember to add your c. Okay, dividing by a fraction is the same as times by its reciprocal. So I can just do 6 times 2 is 12. So that's 12 over 3. X to the 3 halves. 4 divided by 2 is 2, minus divided by a minus is a plus, so plus 2x to the minus 2, plus 5x, plus c. 12 divided by 3 is 4, so that's 4x to the 3 over 2, plus 2x to the minus 2, plus 5x, plus c. And you will get your final mark at that stage, but let's just assume you wanted to go further because you're going to use it in another question. This helps us revise indices. So we've got x to the 3 halves. So that's the same as x, the square root, because of the 2, x cubed, plus 2, x to the minus 2 over x squared, plus 5x plus c. But you don't need to go that far for this question. SQA Higher Maths 2019 Paper 2 Question 3 on vectors and vector pathways. It says EABCD is a rectangular based pyramid. It tells you that A to B is P as shown, A to D is Q as shown there, and A to E is R. And we have to express B to E in terms of P and R. So where's B to E? I need to start here and get up to there. So remember, you can take any direction you want. So I can just trace this. I go minus P. So I can write minus P. I've done minus P, and I want to get all the way up to E. So I can go up R, so plus R. And that's it. It really is as simple as that. Point F divides BC in the ratio 3 to 1. Express the vector EF in terms of P, Q and R. So EF, just to be clear, is from here down to there. I want to get to there, but I need to go a path that I can actually use. So we could go along there, down there, and then back to there, and that will give me that. So let's just trace that out. I've got minus R plus P. So let's write that down to start with, minus R plus P. And then once I've done minus R plus P, I need to go along here. You know, how far along am I going? Well, it says it divides it in the ratio 3 to 1. So if I imagine that this whole length is 4, I've went along 3 out of 4 bits. 3/4. And what is B to C's vector? Well, it's the same as this one because it's parallel. So it's 3/4 of Q. So plus 3/4 of Q. And we're done there. SQA Higher Maths 2019 Paper 2 Question 4. It says, in a forest, the population of a species of mouse is fallen by 2.7% a year. To increase the population, scientists plan to release 30 mice into the forest at the end of the year. It says UN is the estimated population at the start of April, n years after the population is first estimated, and it knows that UN and UN plus 1 satisfy this recurrence relationship. State the values of A and B. So for part A, it's really about pulling out the information from the question. So let's have a look at this. We have got it's falling by 2.7%. So to work out A is going to be the percent times UN, but what's left over? So it's 100% minus 2.7%. That gives me 97.3%. So A is equal to 0.973. And then B, we plan to release 30 mice into the forest at the end of each year, so B is 30. And we're done there. Question B. Explain why the estimated population of mice will stabilize in long term. So it mentions stabilizing, so it means a limit exists. So we can say a limit exists since -1 is less than 0.973, which is less than 1. And that's all we need to say. Step 2, calculate long-term population of nearest 100, and I always find the limit. So for part 2, L equals B over 1 minus A. So we'll just plug our numbers in. B is 30, then it's 1 minus 0.973. 30, over 0.027, which is 111.11, 111.11, or to the nearest 100, 1100. And we're done there. The derived function, SQA Higher Maths 2019, paper 2, question 5. The diagram below shows the graph of a cubic with stationary points at -2 and 4 as shown on the diagram of your answer book. Sketch the graph of g-x, the derivative. Okay, so let's just draw a picture here. Y and x. Now, we should first of all look at this. It's telling us it's a cubic. A cubic differentiates to a quadratic, so we're expecting a quadratic either going down the way or up the way, and we really just need to identify the roots. Well, the roots happen when the turning points, because the derivative equals 0. So it's just, I need to know that stationary points occur when y by dx is 0, which means that these are my roots. So I get a root at -2 and a root up at 4. So that means that if we examine before -2, it's going up the way, it's then dropping down the way, and the derivative will be going back up the way. So it's above the x-axis before -2, it's below in between the roots, and it's above again after 4. So that's how I like to think of this. So I know I'm starting high, I'm dropping below between the numbers, and then I'm going high again, so my curve must come down like so. Obviously, I can't quite get the turning point. I know the turning point happens at 1 in the middle of the roots, but I don't know exactly what it would be on the y-axis, so I don't need to work that out. And there we are. There's my graph of the 2019 paper 2 question 6. The wave function express 2 cos x minus 3 sin x in the form k cos x plus a. So for part A, quite standard stuff, 2 cos x minus 3 sin x. Expand the right hand side, that's k cos x cos a minus k sin x sin a. And you're just using the start of the exam paper to see that. So then we'll equate the sides. So looking at what's attached to cos x on this side, I've got k cos a. And that's attached to cos x on this side by 2. And then on the other side, what's attached to sin x is k minus k sin a. And what's attached to sin x on this side is minus 3. Or you could have just written k sin a is equal to 3, because minus minus on both sides. Okay, so we don't really need that one anymore. So then we find our k. So k is, remember, the square root of the two numbers, 2 squared plus 3 squared. That's because sin squared plus cos squared equals 1. So that means that k is the square root of 4 plus 9. So k is the square root of 13. Now we need to find our a. So because tan a is sin a over cos a, and the k's will cancel when you divide them, then that means that tan a is equal to 3 over 2 sin over cos. So you just get your calculator and work out the inverse tan of 3 over 2. Inverse tan of 3 over 2 is 56.3 degrees. And we just need to check if we're in the correct quadrant. We should be, because everything's positive, but just a double check. Cast the diagram. Always checking from your cos and sine. So your cos was positive and your sine was positive, which means positive cos, positive sine. You're in the first quadrant, and therefore A equals 56.3 degrees. Now we just write it in the correct form. So it's root 13, and it was cos x plus A, x plus 56.3 degrees. And we're done for part A. Part B, hence solve 2 cos x minus 3 sin x equals 3. just check, is this side the same as that side? It's either going to be the same or it'll be a multiple of this, which means you do a multiple of that. It is the same in this case, so we can just write our answer equals 3 and solve. So for part B, root 13 cos of x plus 56.3 degrees equals 3. So all we need to do is divide by root 13 to get cos of x plus 56.3. So that is 3 over root 13. And then we can do the inverse cos of 3 over root 13. So the inverse cos of 3 over root 13, using a calculator, gives you an answer of 33.7 degrees. Looking at our cast diagram, one more time, cos is positive, so it's in the first and fourth quadrant, so that's 360 minus. So our second answer is 360 minus 33.7 degrees, which is equal to 326.3 degrees. Now, if our answer was just cos x here, that would be as done, but it's x plus 56.3, so we need to solve an equation. So we can then say, therefore, x plus 56.3 degrees equals 33.7 degrees, and that's our first answer. And our second one is going to be x plus 56.3 degrees equals 326.3 degrees. Solving for x, the first one gives me minus 22.6 degrees, and the second one, taking away 56.3, gives you 270 degrees. So we can then say final answer, x equals minus 22.6 degrees, 270 degrees, but minus 22.6 is out with a range, where it's 0 and 360. So to get another answer, we just take our lowest one and add 360 on. So 360 on from minus 22.6 is 337.4. Always check your range. And then, since that's out with a range, we just disregard that one, and that's our final answer. Increasing and decreasing functions, SQA Higher Maths, 2019, Paper 2, Question 7. Express this in the form p x plus q squared plus r. Now let's complete the square. So for part A, if we look at these two, we can take minus 6 out as a common factor. So we get minus 6, and we get x squared minus 4x. 6 times 4 is plus 24. Take away 25, sitting on the end, and then we just complete the square the normal way on this term. So we've got, that gives you minus 6, half the middle term, x minus 2, all squared, and then immediately take away 2 squared, and we've still got minus 25 on the end. Just be aware that this is all times by minus 6 though, so we need big brackets around it. So that gives us minus 6, x minus 2 squared. 2 2s is 4, 4 6s is 24. So we get plus 24 minus 25 sitting on the end. So that's minus 6, x minus 2 squared. 24 minus 25 is minus 1. Part B says, given that f of x is minus 2x cubed plus 12x squared minus 25x plus 9, show that it's strictly decreasing. So to show that something's increase or decrease, we need to evaluate the gradient of the tangent, and always differentiate. So let's look at f dash x. F dash x equals 3 times 2 is 6, so minus 6x squared. 12 times 2 is 24, so plus 24x, and minus 25. So we've differentiated it, but notice that is minus 6x squared plus 24x minus 25 is exactly what we were asked to do with something with completing the square on part A. So it's to do with the fact that it's completed the square. So we can now just say that f dash x now equals minus 6x minus 2 squared minus 1. If I pick any number for x here and I square it, I get a positive number. So that means I can then say x minus 2 squared is positive for all values of x. And that means that when I've got a positive times a negative is a negative. Take away another one, gives me a negative as well. So all I need to then say is, therefore, minus 6x minus 2 squared minus 1 is negative for all values of x. So f of x is strictly decreasing. And we're done there. SQA Higher Maths 2019 Paper 2 Question 8 on functions and inverse functions. A function f is given by f of x is a cube root of x plus 8. It tells you the domain is 1 between 1 and 1,000, and it's a real number. If inverse function is this, find the inverse function. So how I always do this is I let y equal the cube root of x plus 8, and I'll just rearrange that to make x the subject. So y minus 8 equals the cube root of x. Cubing both sides then, I get y minus 8 cubed equals x, and I then straight away can just jump in and say that the inverse function of x then is equal to x minus 8 cubed. I just swap the y for an x. Do not write at this point here, this is very important. Do not then write y equals nx there, because you've already said that y equals this, so it doesn't equal that with an x in it. Just jump from here to here and you're done. Part B, state the domain of the inverse function. The domain of the inverse function is the same as the range of the original function, okay? So let's check the range of f of x. So I'll just write it down. Range of f of x equals domain of the inverse function. In becomes out, and out becomes in. So what's the range? Well, the range of f of x is just putting in f of 1. Well, that's the cube root of 1 plus 8, which equals 9. And f of 1,000, which is the highest number it can be, is the cube root of 1,000 plus 8. Well, 10 times 10 is 100, times 10 is 1,000, so that's 18. So therefore, the domain of the inverse function is 9 is less than or equal to x is less than or equal to 18. And we're done there. It's between 9 and 18. Solving exponential equations, SQA Higher Maths 2019, Paper 2, Question 9. Electricity on a spacecraft can be produced by a type of nuclear reactor. The electrical power produced by a generator is PT equals 120e to the minus 0.0079 t. Don't be put off by this t, it's just part of a symbol to tell you that p is a function of time. Where PT is the electrical power in watts after t years. Determine the electrical power, keyword, initially produced by the generator. So if it's initially produced by the generator, that means part A, when t equals 0, PT equals 120 e to the minus 0.0079 times 0. Well, that gives you P of t equals 120 e to the power of 0, which is 120, because e to the power of 0 is 1. So we're done there. We could put the units in just to be clear. Watts. Part B, calculate how long it takes for the electrical power produced by the generator to reduce by 15%. So let's reduce this by 15% by doing a little bit of maths. If it's reduced by 15%, there's 85% less. So that means that the power is going to be 0.85 times 120. And you just get a calculator out for that to get 102. So that's our new power. So that means that 102 equals the initial power, 120, e to the minus 0.0079 t. And we're going to solve for t. So it's an exponential equation, so I can divide through by 120 to get 102 over 120 equals e to the minus 0.0079 t. That gives me 0.85 on this side. E to the minus 0.0079 t. And if we're working in percentages, you'll realise that this number here will be basically what the question's asked us anyway, but I always start from here just to be on the safe side. So then we can log both sides using the natural log of 0.85, or log e of 0.85, equals the natural log of e to the minus 0.0079t. Pretty standard stuff. That means that log 0.85 equals, take the power down, minus 0.0079t times the log of e. But the natural log of e is 1. So that means that log 0.85 is just equal to minus 0.0079t. And therefore t is the natural log of 0.85 divided by minus 0.0079. And we can just get our calculator out and place log 85 over 0.0079, with a minus in front, of course, and you'll get 20.6. And the units were years. Maths 2019, paper 2, question 10 for factors and remainders. Show that x plus 3 is a factor. So part A, synthetic division. We've got 3x4, 10x cubed, 1x squared, minus 8x, minus 6, plus 3, so we're subbing in minus 3. So take the 3 down, we get minus 3 times 3 is 9, minus 9, 10 minus 9 is 1. 1 times minus 3 is minus 3, minus 3 add 1 is minus 2. Minus 2 times minus 3 is 6, 6 minus 8 is minus 2. Minus 2 times minus 3 is 6, 6 minus 6 is 0, and therefore since the remainder equals 0, x plus 3 is a factor. Part B, hence always factorise it fully. So we've already done a little bit of the work. We've got x plus 3, and then these all drop down a power, so it's 3x cubed to start with, plus x squared, minus 2x, minus 2. Okay, so we've now got a cubic to factorise, so we need to find a factor of this. You can just do that by trial and error, trying 1, minus 1, and so on. So let's start off by trying 1. So for this one here, we've got 3x cubed plus 1x squared minus 2x minus 2. We try 1, and if 1 doesn't work, we try 2 and 3 until we get the remainder of 0. So 3 goes down, 3 ones are 3, 3 plus 1 is 4, 4 ones are 4, 4 minus 2 is 2, 2 ones are 2, 2 minus 2 is 0. Like again, you might have to do that a few times, and you don't have to use synthetic division each time. You can just substitute a number in direct if you want. But I've done it in 1, so I now know that since the remainder is 0, x minus 1 is a factor. And therefore, we now know we've got x plus 3, x minus 1, and we've got our 3x squared plus 4x plus 2 from the bottom bit. So now we need to check, is 3x squared plus 4x plus 2 factorisable? There's a couple ways you can do it, trial and error, but the easiest way is to use the discriminant. If I look at, I'll do this in red, this bit here, and check b squared minus 4ac. b squared minus 4ac is 4 squared minus 4 times 3 times 2. That's 16 minus 12 times 2 is 24, which is negative 8. That means no real solutions. Final answer is x plus 3, x minus 1, 3x squared plus 4x plus 2, and we're done there. Question careful, it's really just an optimization question. Have a look, see if you can have a go at it, and then come back when you're done. Minimize the cost of production, minimize optimization. That's your key power word for higher maths there. Let's try part A in any case. So there is our box and all the information in it, and I want the surface area. So I'm just going to start working on it and see if I can get the answer close to what they have got. So surface area, we've got 3x times h, and I can see I've got 1 of them, 2, 3, 4 of them. So first of all, I can write down I've got 4 times 3xh. I'll put a dot for times in so it's clear. And then I need to add on, well, I've now got my top and my bottom. So my top is going to be 3x times 3x, so that's 9x squared, times that by 2, so plus 9x squared
plus another 9x squared, just to be clear, but or 18x squared straight away. But then you've also got a whole in the top, which is x squared by x squared, and I've got two of them, so take away 2x squared straight away. And then the bit that everybody can't always forgets, I almost forgot it, there's a surface inside this tube as well, so I need to work out what that surface is. Well, there's going to be 4 of them, and it's just going to be x times h. So plus 4xh. Tidying all that up a little bit, my area is 12xh plus 4xh. That's just my first and my last one. And then my x squared's 9, 18 minus 2 is 16x squared. Or my area is 16xh plus 16x squared. If you can get that far, you're getting a mark. But we're not finished there because our area in the question's not got any h in it. So we need to work out if we can eliminate that h somehow. Well, let's look at the information. The volume is 2000. Well, volume is length times breadth times height. So if I write that down underneath, volume is length times breadth times height. Volume of the big box, which is 3x times 3x, which is 9x squared times h. So 9x squared h, but we need to remember to take away the whole, which is x by h, so that's just x squared h. So our volume, 8x squared h, but that equals 2000 it says. So I can now eliminate h from my area by rearranging this equation to make h the subject. So that means that h equals 2000 divided by 8x squared. A mark for getting h. Now we just need to substitute it into a. So our a is 16x times h, 2000 over 8x squared. And we've got still plus 16x squared. Using a calculator, 16 times 2000 divided by a is 4000. So we get 4000 on the top. And we've got cancellation to do, x on the top, so x squared becomes x. So we get x on the bottom, plus 16x squared, or writing it in exactly the same way we wanted, 16x squared plus 4000 over x, which is just exactly the same as what I've just already got. And there's your third and final mark. Part B said, to minimize the cost of production, the surface area A of the box should be as small as possible. Find the minimum value of A. Minimum value optimization. Let's jump straight in. So part B, I want to optimize the area. To differentiate a function, we need to get it ready. So let's start with our area. We've got 16x squared, but I'm going to have to take that 4000 x to the minus 1. So I can differentiate it. And you'll actually get a mark straight away there for getting it ready. We now differentiate it. So a dash or a dash x, 2 16s is 32x minus 4000 x to the minus 2. And that's me differentiated it for a mark as well. So 2 marks out of 6 so far. Now, if we fix that by making it equal to 0, because we're optimizing. So remember, stationary points occur when a dash x, I'll call it, equals 0. So we can say 32x minus 4000 x to the minus 2 equals 0. For realizing we had to do that and find stationary points, we get another mark. And then we need to solve it. We'll get another mark in a moment for solving it, but I'll show you all the working you need for solving it. So we've got 32x equals 4000 over x squared, we could say, x to the minus 2. So multiplying through by x squared, we get 32x cubed equals 4000. Dividing through by 32, 125. So x is the cube root of 125. There's only one answer to that. It is 5. So we now know that x is 5 is our turning point. But we need to prove and show that that is a minimum. We don't know if it's a minimum or a maximum. So we need to do a table of signs. So let's do our table of signs just to show that. x, going along 5, and we're going along. A dash x, so a number less than 5, but not 0, because 0 is undefined. Then if you picked 1, say, you would get 32 minus 4,000 over 1. That's a negative. So we've got negative 0. Hoping that after 5 is positive, but you can check. Just get yourself a calculator, pick a number close to 5. Let's pick 6, say. 32 times 6 is 192. 4,000 divided by 36 is 11. That minus 11 is positive, so we can say it's positive. So our shape is down, along, and up. Therefore, x equals 5 minimizes a. So to get a, remember, x equal to 5, we work out our area equals 16 times 5 squared plus 4,000 over 5, 1,200 for your final mark. A note in table of signs here. Technically, this is one of those ones where the function is discontinuous. In other words, at 0, because if you can't divide by 0, it breaks. You have to make sure that you've kind of shown that it's in the neighbourhood of 5. I always draw an arrow because the SQA take it to mean a number close to 5, a number close to 5 on either side. If you do that and don't actually say any numbers, you will be fine. Relation from a straight line for logarithmic graphs. SQA Higher Maths 2019, Paper 2, Question 12. Two variables x and y are connected by the equation, and this is what you're looking for. Y equals ab to the x, a power. And we're looking at one of the axes is logged, but the other one is not. So it's only one log this time, but always start from your equation and get the logs coming out and see where you go. So I'll start with y equals ab to the x. We have to find the values of a and b. So let's start with y equals ab to the x. Just log both sides then. Our log base is 4, so looking on our graph, log base 4y equals log base 4 of ab to the x, which is a product. So I can separate that into a plus. So log base 4y equals log base 4 of b to the x. So like the x one first, like mx plus c, plus log base 4a. Taking the x to the front, we get log base 4y. That's a y and that's a log. Equals x times log base 4b plus log base 4a. Well, y equals mx plus c is our straight line, so let's put the x on the end so you can really see it. Log base 4y equals log base 4b times x plus log base 4a. So that's like y equals mx plus c. So we can see our gradient is equal to this number in front of x, and our c is equal to this. So we can say our gradient is equal to log 4b. So let's just check our graph to see if we can work out the gradient. We're given 2 points. So our gradient is equal to y2 minus y1 over x2 minus x1. So that's 8 minus minus 1 over 3 minus 0. That's 9 over 3, which is 3. So we know our gradient's 3. So log base 4b equals 3. Remember, that means that 4 to the power of 3 equals b. 4 cubed is b. 4 cubed is 64, and therefore b equals 64. Now let's try our c. From the work we've just done, our c is equal to log base 4 of a. C is where it cuts the y-axis. We know it cuts the y-axis at 0, minus 1, so c is minus 1. So we can just straight away say that minus 1 is equal to log base 4 of a, or if you prefer, log base 4a equals minus 1. Remember, that means 4 to the power of minus 1 equals a. You can just write that straight away. 4 to the minus 1 equals a. 4 to the power of minus 1 is 1 over 4 to the power of 1. So therefore, a equals 1/4. And we're done there. Equations SQA Higher Maths 2019, Paper 2, Question 13. A function defined a set of real numbers. It is shown that the rate of change of f with respect to x is given by this equation. the graph of y equals f of x crosses the x-axis at 7, 0, express f of x in terms of x. This question, I suppose, is asking you about do you know what rate of change is? Well, rate of change means differentiation. So we know that f dash x equals 3x squared minus 16x plus 11. So that means that f of x is the integral of this. And we'll get to the second bit of information to get c in a minute. So integrating that, we get x cubed times 3 over 3 minus 16x squared over 2 plus 11x plus c. So there's our initial step. We can simplify that in a moment, but it tells us that the graph of y equals f of x crosses the x-axis at 7, 0. Well, 7 is x and 0 is y. So we can substitute 0 and 7 into our equation. So we've got f of x, tidying it up, equals x cubed, minus 16 over 2 is 8x squared, plus 11x plus c. So when x is 7, y is 0. When x equals 7, y, which equals f of x, equals 0. So subbing that in, we get 0 equals 7 cubed, minus 8 times 7 squared, plus 11 times 7, plus c. This was a calculator paper, so you could do all the sums in a calculator, but 7 cubed is 343. 7 squared is 49 times 8 is 392. 11 sevens is 77. And then we've got plus c, and 0 equals this. Tidying all that up, we get 0 equals 343 minus 392 plus 77 is 28 plus c, and therefore c must equal negative 28. We've got our c, so we'll just sub it back into the equation we just found above. So therefore f of x is equal to our x cubed minus our 8x squared plus 11x minus 28. And we're done there.
SBA Higher Maths 2019, Paper 2, Question 14, Magnitude and Scale Product of a Vector. We've got two vectors u and v such that the size of u is 4, the size of v is 5, and u dot u plus v is 21. Find the size of the angle in between. So let's start off with, if we look at the start of the exam paper, a dot b is size a, size b, times the cost of the angle in between them. So we're going to kind of use that fact. So we've got u dot u plus v, well we can expand that just by saying we've got u dot u plus u dot v. So u dot u is equal to the size of u times the size of u times the cos of theta. But what's the angle in between a vector and itself? Well, it's nothing, so it's the cos of nothing. Plus the size of u times the size of v times the cos of theta, because we don't know that angle, but that equals 21. Well, the cos of 0 is 1. So we've got the size of u times the size of u, 4 times 4, times the cos of 0 is 1, plus 4 times 5 times the cos of theta equals 21. So that gives me 16 plus 20 cos theta equals 21. 21 minus 16 is 5, so 20 cos theta is equal to 5, which means that cos theta is equal to 5 over 20, or a quarter. So then, put into our calculator, the inverse cos of a quarter. That's 75.5 degrees. And it is just the angle in between the two vectors is acute, so we don't need to do a cast diagram or anything like that. 75.5 degrees is our answer. So theta equals 75.5 degrees. And we're done there. SBA Higher Maths 2019, Paper 2, Question 15. A circle has centre 8, 12. P 513 lies on the circle as shown on the outside. Find the equation of the tangent at P. Now, if we want to find the equation of the tangent, if it's about circles, a tangent meets a radius at right angles. So we can find the gradient of the radius, and then m1 times m2 equals minus 1. So we'll just do that. Let me just draw that picture in so it's really clear. That's a right angle. So the gradient of C to P, or P to C, is 13 take away 12 over 5 take away 8. That's 1 over minus 3, or minus a third. So the gradient of our perpendicular equals 3, since m1 times m2 equals minus 1. And we've got our point. Our point is 513. So it's just now straight line work. Y minus b equals mx minus a. So y minus 13 equals 3x minus 5. Y minus 13 is 3x minus 15. So y equals 3x minus 2. And we're done there. Part B says the tangent of P meets the y-axis at point T. State the coordinates of T. Part B, aye. Remember, the equation of our tangent is 3x minus 2. So it meets the y-axis when x is 0, in other words, minus 2. So the point is just equal minus 2. And we're done there. So part B2 says find the equation of a circle that passes through the points C, P and T. So if we've got the picture of it here again, we've got C, P and T, and we're saying that there's some circle that goes through all three of these points, a bigger circle. Now, if I've not drawn an accurate sketch of this, but we know that this is a right angle it's meant to be at P. Now that only happens in a circle when we make a triangle, and that would be the diameter. So we now know essentially that CT is the diameter, and therefore we can work out the midpoint of C and T. So the midpoint of C to T, well, we've got 8, and then that is, remember, T is 0 minus 2, so it's 8 plus 0 divided by 2, and it is 12 minus 2 divided by 2, so that's 8 over 2 is 4, and we've got 10 over 2, which is 5. So we know our midpoint now is 4, 5. Now we need to know the radius, so we can do the distance between C and T. Remember, T is 0 minus 2. So the distance from C to T equals the square root of 4 minus 0 squared is 4 squared, and then 5 minus minus 2 squared is 7 squared. So it's 4 squared is 16 plus 49. That is the square root of 65. And therefore the equation of a circle that goes through these points is simply x minus 4 squared plus y minus 5 squared equals 65, root 65 squared. And we're done there.